Okay, so if I'm looking at this, if it would unfreeze, there we go. What do I need to do first? Count all those tiles, right? So take a second, count, and write yours in. Count those tiles, write them in. Okay, how many did you count for figure 1? Did y'all count 18? How many for figure 2? 16. Figure 3? How do I get from 18 to 16? So we need to write that in between them. So how would I get from figure 3 to figure 4? Minus 2 again. So what is 14 minus 2? 12. How would I go from figure 1 to figure 0? Not minus 2, but plus 2. Remember, it's the exact opposite. So what is 18 plus 2? Where are the tiles being added? Well, subtracted in this case. Tell me your direction again. I didn't hear your direction. Which side? The right. How many from the right? 2 at a time. So I'm taking this one and this one. Because do you see how I take this one and this one away? It gives me the original one right here. And then if I take away those 2 again, goodness, it would give me back that. Everybody still with me? Everybody still there? Okay. This is working in the opposite direction because when I take it away, I get the next one. So, if you see the inner part right here, this piece, that's going to be figure 4. Does that make sense? So, just redraw this inner piece, and that's figure 4. So, I should have 3 columns of 4. So, I should have 12. Let's do that. Remember, this doesn't have to be perfect. We're looking for precision. Denver, did you get to work on these already? Good. Did you get the same thing? Very proud of that. So, any questions on how we drew figure 4? Now, figure 0 should be bigger than that of figure 1 because what am I adding? 2 more, right? So there should be 2 more in this gap that's right there. So now I should have 1, 2, 3, 4, 5 columns of 4. Does that make sense? Everybody still with me? So, let's do that. And to fulfill what I was being asked to do, I would have to take away those 2 right there. That's what I mean by shade any subtracted tiles. Because I have to take those 2 away to get this figure. I have to take those 2 away to get this figure. Take those 2 away to get this figure. And take those 2 away to get this figure. Does that make sense? Do we see how this is going in the exact opposite of the other examples that we've done? So I'll make sure your hood's off, honey. Yes, no? Use your words for me. Do we see the changes? But do we see how it's exactly the same? So, any questions on how we drew the tile pattern? How would I fill in my table? What does X represent?
Figure number.
Figure number. So what goes in that tile? In that table part? 0, 1, 2, 3, 4. What does y represent? So what goes in 0? In 1, in 2, in 3, and in 4. Do we see how it's decreasing from left to right? Any questions there? What's the initial value for this pattern? 20. How much is the pattern decreasing by? What kind of 2? So do I need to put the negative? It's different than how we did the positive ones. You could put the plus or you can leave it as is. But in this case, you always have to put the negative. How would I write an equation in slope-intercept form that relates the figure number x to the number of tiles y? Are we sure about that? Think about what you just said. What was it? 20 minus 2x, but that's not slope-intercept form, is it? How do I write that in slope-intercept form? Y equals negative 2x plus 20. Because what variable is this? No, what variable is this? It's what? Don't say nothing without looking. We've learned that lesson. What variable goes with this? M. Does M come second or first? First. Because how do I write slope-intercept form in general? Y equals what? Mx plus b. Did I say b plus mx? What did I say? What's written? So what needs to come first? Mx. What does initial value go with? What variable? 0 what? Thank you. Remember, not 6, b. Any questions there? So this is what you're looking for. Any questions there? It says use your equation to find the number of tiles for figure 10. So what am I trying to find here? So am I looking for x or y? What am I trying to find? What represents the number of tiles? Are you reading? Are you asking me or telling me? Why are you telling me that? Thank you. You see how he just said that for me? But I made him say it with what? Confidence. Because are we supposed to be scared in here? No. What are you scared of? Me teaching you the lesson? Or are you actually reading and understanding it? You shouldn't be afraid of either one. Okay? So great job, Brandon. Confidence. It says it right up here. The number of tiles is what? Y. So what are we looking for? So you need to write that. We're looking for Y. Find Y. So what did they give me? So what information did they give me? Which is what? X. So X is what? Or X is just what? Equals to 10. Should we be writing this kind of stuff down? Absolutely. Because is it going to pop back up? With the violence, right? Don't let this violate you on no test or no quiz. Handle your business, okay? Y'all got the material. You just need the push. So, how would I set this up, given the equation I have? Absolutely agree. Am I simplifying or solving here? Is this a case 1 or a case 2? Meaning from function evaluation. This is a case 1 because we gave an x. So is it simplifying or solving? Simplifying, because I'm not having to move any variable. I'm just simplifying one side to get my answer. So, what do I need to do first? What's negative 2 times 10? And then what comes down behind it? Absolutely. What do I do from there? Absolutely. So typing in negative 20 plus 20. That gets you what? So how would I write my answer? 0 tiles. Because they told me to find the number of what? So I should have that in my final answer. Any questions there? Everybody good? Okay. That was the review. Number 6, treat it the exact same way as how we just did number 5. I'm coming around with your papers. Make sure your name and date's on there if you do not mind. This is talking about transformations. Transformations is just saying, are we going up, down, left, and right? That's really it. And lucky for us, linear functions, bless you. I don't know if that was sneeze or not true, but it was a cough. Okay, well, premature bless you for later on in life. So, transformations for linear equations is very simple because we're dealing with what kind of shape? A linear function has what kind of shape? A line. So is it hard to see where a line is moving? No. If it goes up, we can see that. If it goes down, we can see that. If it goes left, we can see that. If it goes right, we can see that. We do that by looking at key pieces and factors of that shape. So let's jump on in. I don't know if y'all ever watched the movie Jump In with Corbin Bleu, but 10 out of 10. That was peak Disney. Hot take, I said what I said. Yeah, Push it to the limit. Bye. Either that or a good Kim Possible movie. 10 out of 10. Y'all don't realize, back in the day, they used to have like the games, the online games that went with it. So it made it so much more fun and enjoyable. Like, nothing's more fun than having Kim go to Club Banana. That was the name of their clothing store, was Club Banana, and find an outfit. They made that a game. And you had to fight people while shopping for clothes. How realistic is that?
Every Black Friday.
Honey, could never be me. So let's look at this. Every transformation is based off the parent function. Please highlight or underline. Put an asterisk next to that. That's a little snowflake thing that you typically see your teachers do all the time. It's this thing. That's an asterisk. Every transformation is based off of the parent function, whether it be y equals x squared, y equals x cubed, y equals the square root of x. You get the idea. But we're talking about linear functions. So it's y equals x at all times. So what is my m of this function? What is my slope? What's in front of x that I cannot see? 1. What's my b of this function? 0. So we get that by looking at my y-intercept, which is what that is. And I find my slope by moving up 1 and to the right 1. That's called a slope triangle. I try my best to color code for y'all. That way you can see where everything's coming from. Does that look good? Does that make sense? Okay. When those numbers change, we have a transformation. When m and b change, we have a transformation. So let me put m and b next to where it says numbers. When those two pieces change, then we have a transformation. Gavin, focus, baby. Focus this way. I don't know what's happening outside, but let them stay out there. That's the ghetto. We in here, okay? The streets ain't calling us yet. Not yet. Y equals mx plus b. Everybody still with me? If you see a negative sign, that piece right there, that means a vertical reflection. That means it's going to completely flip and change how the graph is going to sit. I'm trying to put it where you can see the equation and what I'm doing. So if this is my original parent function, which I'm going to highlight in this purple color right here, this one. This is my parent function on each one of these graphs. So I'm going to color it the exact same way. That way you know how we're comparing it. Do you see how this one completely flipped and it's going in the opposite direction now? That's because we changed our slope negative. That means it reflected across the x-axis there. Not the x-axis, the y-axis technically. But we're flipping it, which is creating a negative slope completely. VR for short. M. It's the question of, did it get steeper or did it get flatter? Steepness means when it becomes more vertical. Flatter becomes more horizontal, okay? If you need to write that in, write it in. So this is becoming more vertical, and this is becoming more horizontal. So, as m gets greater than 1, it's this many times steeper. So if you notice, this changed to a 2, so it made my line more vertical than my original one. You see how it went up vertically? This is where we started, that's where we are now. That means from where I started at the origin, I went up by 2 here, and I went to the right by 1. That changed a lot from the first one. I went up by 1 and left by, well, right by 1. Excuse me, my words are getting so mixed up today. That's okay. Any questions on that? Everybody still with me? That's the key part of that. B, meaning when I change my y-intercept, I'm going left to right, so I'm going to get to these bottom ones where they relate in just a second. If B is positive, meaning we add more to B, the vertical shift means it goes upward. Is it going up or down? In this case, we changed our 0 to a what? A what? A 2. So is that greater than or less than 0? So did it go up or did it go down? It went up because it went from 0 to 2. Does that make sense? So from there, what happens when my B becomes negative? Where is it going to go? Because what did this turn into? So from 0, I went where to negative 2? Down. Everybody still with me? Everybody still there? If m is between 0 and 1, if m is between 0 and 1, that means it's becoming so many times flatter. So, what did I change my 1 into for this one? 1/2. So, it became 1/2 times flatter than the original one because it went down towards horizontal. It's going down towards the x-axis. Everybody still with me? Still making sense? The negative on the slope is separate from the actual number. The negative is a vertical reflection. This tells us if it is steeper or flatter. So, the number on the slope is separate from the actual number. The negative is a vertical reflection. The number itself tells us if it is steeper or flatter. So that negative, even though it's attached to m, it means its own transformation. Everybody still with me? So let's look at some examples here. The directions say describe the transformations from the parent function y of x. Remember, the parent function is m and b. So what goes in front of x? What goes in front of x for the parent function? 1. And what goes back here?
0,
So what is my M?
1,
And what's my B?
0.
Any questions there? So, y equals negative x. M is what? And what's B?
0,
So what was the transformation? It was a flip back. Go look. What actually changed between the parent function and this one? What makes this different than that? The negative. So what happened? A vertical reflection. Because did anything else change? No. It's just that one piece. Everybody still with me? Look at number 2. Y equals 2x minus 4. What's my M?
2.
Just 2. Remember, it's the number. You don't take the variable with it, okay? What's M?
-4. Oh, okay.
So, do I see any negatives in front of M?
No.
But did M change from 1
Yes.
into what?
2.
So, if M became greater than 1, what happened? A vertical shift, how? What do they list afterwards?
Oh.
How though? It's not the same way that you're saying it. Are we sure it's a vertical shift? Because what does vertical shift go with? M or B?
B.
B. What is 2?
M.
M. I'm teaching you how to do what? Bless you. Read. So, find where it says M. Look at it. How do you describe 2 compared to 1?
Oh.
How do you describe 2 compared to 1?
2 is greater than
2 is greater than 1. So does it go with the top example or the bottom one? The top one. So what does it say after the equal sign? If M is greater than 1, it equals what? Something times steeper. So what goes in that blank where the number sign is?
Oh, -2.
No.
Non-negative 2.
2 what?
-2.
2. What comes after that? What's the 2 words? Number blank blank. I'm showing you times steeper. You see how I'm teaching how to do what?
Read.
Did I add anything extra? So I'm teaching how to do what?
Read.
We need to get better at it, yes? Do we get better at it by waiting for me to tell you the answer? Or by investigating on your own? Because I'm looking at your same notes in front of me. So which means I marked it. Are you reading it? Okay? Moving on. Is that the only thing that changed?
No.
What else changed? Between here to here, what changed?
B.
B. So, am I looking at what? What part? What kind of transformation is this? A vertical shift. How so?
Okay, change to 0.
Vertical shift how?
So, down.
Down.
4. -4.
Down by what?
4.
Just 4. Because you don't have to say -4 because the word what is there? Down. That means inherently negative. Any questions there? Number 3, I have y equals 3/4 x. What changed? M. What does M become?
3/4.
And what's B?
0.
Still 0. So, do I see any negatives? No. Do I see any changes in M? Yes. So, how did M change?
Became 3/4.
It became 3/4. The question here is 3/4 greater than M or less than M? Well, less than 1, sorry. Is it greater than 1 or less than 1? How can you quantify 3/4 in real life? What's a real world application of 3/4 that y'all use every day?
Pizza.
Not pizza,
Pie.
not pie. When do y'all have pie on hand?
Pizza.
Yes, Gavin.
No, I was saying I got pie.
Bye, Gavin.
Pizza.
Not water. Close though.
Money.
Where does 3/4 come in when you're talking about money? 3 make up a 3/4 of a dollar. So 3/4 is,
Less than.
how much is 3/4 worth? 0.75 is the decimal for 3/4. That's where y'all use it the most in life. Because weren't y'all putting money together not even 2 weeks ago to try to buy something off Snack Cart? Yeah, y'all was like, I put in a quarter, he put in 25%. Does that make sense? I put in 2 quarters, he put in 50%. Together they put in 75% of that dollar. Does that make sense? Ian, what doesn't make sense about that? What do you mean it doesn't make sense? Do you use money? So, do you not understand how money is quantified? So we probably need to learn how to count money, yes? If you would like to learn, come and find me at a different time, because that's a different type of counting. That's not what I do in here, but if you don't know what 75 cents is, we have bigger fish to fry. Looking at this, is it greater than or less than 1? Let me hear you say it with confidence. Less than 1. So, what am I looking at? I'm looking at M. So am I looking at the first section, the second section, or the third section? The second section. Am I looking at the top or the bottom? The bottom. So how would I write my transformation here? What would come first? 3/4 times flatter. Everybody with me still? Look at y, number 4. Y equals 4/3 x plus 9. What is my slope? 4/3. What's my b? So, do I see multiple transformations here? What's the first one I see? 4/3 what? Is that my first section, second, or third? Second yet again because it affects M. So 3/4 what? Times. Type 4/3 in your calculator for me, please, and thank you, and tell me the decimal that you get. Do not change it back into a fraction. 4 divided by 3, hit enter. So I see 1.3 repeating. Do you see the same thing? You see I don't see that with a calculator? Crazy how that works, right? Is that greater than or less than 1? Greater than, because I'd rather have $1.33 than just $1, because that means I have more than what you have. Make sense? So, looking at that, you just said it was greater than 1. So am I looking at the top or the bottom example? The top one. So what comes after times? Steeper. That becomes more vertical. If you don't know that, write down these decimals next to it. This is 0.75 and this is 1.3 repeating, which makes this less than 1, greater than 1. That's what I would write. If you're someone that's like, I don't get where that's coming from, that's where it comes from. But am I done with my transformations on this one? No. So what do I need to do? B as well. So am I looking at the first, second, or third? The third one. Am I looking at the first or the second one? The first one, because 9 is positive, yes? So how do I write that? VS for vertical shift, correct? Up 9. Up means positive, so I don't have to put plus 9. Any questions? Everybody good? From there, number 5. What's my M? -1. What's my B? So from there, and I'm color coding as I go, so if you're wondering what I'm doing, that's what I'm doing. How many transformations do I have?
2.
Just 2. What's the first one? That -1, which makes it a? Huh? Yeah, I said -1, which makes it a what transformation? Nope, you're not reading, you're guessing. Don't say, oh. What'd you say? Vertical reflection. Because isn't that the very first one? Let me pause for just a second. This is y'all's notes right here. Does that say vertical reflection right there?
Yeah.
Isn't it pointing to the negative?
Yeah.
So, did you have to look harder to know where that's coming from? No. From there. What's the other transformation? What was it? Vertical shift.
Down.
Why would it be up and not down?
Oh.
Because it's positive. It's okay to make mistakes here. It's not okay to make mistakes on that test. So which means hold yourself accountable. Any questions there? Number 6, y equals 9x minus 10. Y equals 9x minus 10. What's M?
9.
What's B?
Negative 10.
How many transformations do I have? 2. What's my first one?
Oh.
So how would I write that? 9 times steeper. What's my other transformation? What was it? VS what? Down what? Any questions there? Looking at number 7, I have y equals 1/5 x plus 1. What's your M? What's B? How many transformations do I have? What's the first one? What was it? The 1/5? So what is that? It affects what variable? M. So I'm looking to see if it's what or what? Steeper or flatter. So if you don't know the decimal for 1/5, can you find it easily in your calculator? Type that in for me. 1 divided by 5. What'd you get? So I have 0.2. How does that compare to 1?
It's less than.
So is it steeper or flatter? So how do I write this?
1/5
Times flatter. What's my other transformation?
V. Well, VS.
Mm-hmm.
Up 1.
Agreed. Any questions there? Everybody good? Look at number 8. I have y equals negative 5x plus 9. What's my M? What's my M, sorry? Negative 5. What's B? How many transformations do I have here? Are you sure?
Well, 1.
Are you sure?
It's 2.
But I don't agree with you. Because are you reading? Flip over to that first page. Look at that bottom section of 3 sentences. So bottom left, those 3 sentences, because I'm looking right at it as well. They all end with exclamation points. What makes it 3 and not 2?
Because.
What was that? Because the negative. That sounds like that is 3 separate pieces to me. How about y'all? Because somebody read what that bottom left corner says real quickly for me. Read it out loud if you don't mind.
Negative on the slope is separated from the actual number. Negative or the number is the steeper or flatter.
You see how those are 3 separate sentences? It's telling you that the negative is a what? So that should be the first thing we write from left to right. And then the number tells us what? If it's perfect. How does 5 compare? Not negative 5, just 5. Because you take the absolute value when you do that. So, what is the absolute value of negative 5? It's 5. How does 5 compare to 1? It's greater than it. So what should it actually be? 5 what? 5 what? Say it all together. Times what? You have to take the absolute value. This piece is so important. I can't stress it. Because people see the negative and they go, that's less than, but you're not talking about the negative, you're talking about the 5. And what's the last transformation? VS what? Any questions there? That one was a journey. It should be. Chill. Look at number 9. I have y equals 8 fifths x minus 6. How many? Well, what's my slope? We'll start there. What's b? How many transformations do I see? Just 2. What's the first one? 8 over 5. So what question am I asking for that? Is it greater than or less than what? Is 8 over 5 greater than or less than 1? Greater than, because what decimal does it give you? 1.6. So, how would I write that transformation? Times steeper. Bless you. What's the other transformation? Great job. Any questions there? Looking at 10. I have y equals negative 5/8 x. How many, well, what's my slope? I'll always start that way. Negative 5 over 8. What's my b? How many transformations do I see? What's the first one? No, yes, because of what? And then we take the absolute value of negative 5 over 8, which gets us 5/8. Well, 5 over 8. Is it greater than or less than 1? Less than 1. So how would I write this? Great job. I put an asterisk next to those two that I had to take the absolute value of. Very quickly, do me a favor. Do number 1. The bell's going to catch, but I want you to do number 1. I want to see how you're looking at this. When you're finished, bring it to me.